So matrix multiplication is what we're going to be doing for the next 2 days. And you should have paper and pencil and be ready to go. So you don't have to write this down, but with matrix multiplication, you pretty much do everything that you would do with just all real numbers, right? So when you are multiplying a matrix by a constant, it still creates a matrix. You can multiply in whatever order when it comes to multiplying a matrix. That's why it's called associative property. Distributive property, if you have a constant being multiplied over addition, you can distribute and then multiply, or same thing, identity property. A matrix times 1 is itself. Property of 0, matrix times 0 is going to be 0. Closure property, so everything that we can do, we will still apply. It just may look a little different. So all the things you've learned about multiplication still apply with multiplication, with matrices. All right, so first thing we're emphasize is scalar multiplication. And what that is to multiply a matrix by a scalar, which is C, and you multiply each element of the matrix by that value. So for scalar multiplication, you're going to multiply each element by that value. So for example, if I had matrix and my scalar is 2, then the resulting is going to be 2, 4, 6, 8. Because I would multiply every element by 2. Make sense? Okay. Now, this is just the foundation of it. This is used to solve and evaluate. So let's evaluate. So notice here it says we have matrix A, matrix B, and we want to know what is 4A plus 3B. Okay, so just like with any other order of operations, you multiply first and then you add. So we're going to find 4A and find 4B, and then we're going to add them together. Okay, so if I'm looking for 4A, that means that every element in A is going to be multiplied by 4. So my 4A becomes 8, -4, 32, 20, -12, and 8. Are we comfortable with that? Okay, and then I need to find 3B. So for 3B, that means every element in B is going to be multiplied by 3. So that gives us -3, 0, 0, 9, 15, and -6. So we did our multiplication first, and now we can add. So now we're going to evaluate what. It's just the same way we added yesterday, where it's element by element. So now we're going to find 4A plus 3B. Remember, when you're adding, it's element by element. So corresponding element. So 8 corresponds with -3, right? So it's 8 minus 3 in that one. I'm going to write them all out. So -4 plus 0. 32 plus 0. 20 plus 9. -12 plus 15. And then we have 8 plus -6. So 8 minus 6. And our resulting matrix would be 5, -4, 32, 29, 3, 2. So that's what I was saying. All the same things that you've been doing with your regular whole numbers still apply, right? It's just that it's in a different format. And so it may look a little different, but it's the same thing. We multiply, then we add. We follow our order of operations. Cool? All right, so I'm going to give you guys a moment to practice it. Okay, so the first thing you should have done was count your 3a. And for your 3a, you should have gotten 6, -3, 24, 15, -9, and 6. Then you should have found your 2b. And for 2b, you should have gotten -2, 0, 0, 6, 10, and -4. And now you're, yes. +2. Wait. -2? No, I didn't distribute the negative. I just distributed the 2. I waited to do my subtraction. Is that what you're asking me? It was a -2. Because it's 2 times -1. And then we have 3a minus 2b. So when you take each element, so we have 6 minus -2, you should have gotten +8. So in the first row, we have 8, 24, -19. And the second row, we have -3, 9, and 10. How do we do? Okay. If you chose to distribute the -2, then you would be adding them together. Okay. So these are evaluating problems. So we just finished evaluating practice. Now we're going to move into solving. Okay. So solving means you're missing something, right? We're missing a whole matrix here. And so we're going to solve to figure out what the element of that whole matrix is going to be. All right. So just like anytime else you would solve, you want to go ahead and multiply by the scalar. So we want to multiply by 3 first. So how does multiplying by 3 transform this? It now becomes 2 matrix X plus 6, 9, -3, 12 equals 8, 11, 5, and 0. Okay. When you think about this X, it's like having 4 little unknowns, right? Because this isn't just an X, it's a matrix. So X actually equals X sub 1. I'm just going to write it next. You have 4 that you do not. You have 4 unknowns. So that matrix represents 4 unknowns. So we're going to set up equations. So when we set up our equations, you're taking 2 and you're multiplying it to each one of these, right? So it'll be 2, 2, 2, 2. So what we're solving is 2x sub 1 plus 6 equals 8. 2x sub 2 plus -3 equals 5. And you have to figure out what each one of them is. So we have 2x sub 1 plus 6. And what does that have to equal? 8. And then we have 2x sub 2. Let me write -3. -3 equals 5. Bless you. 2x sub 3 plus 9 equals 11. And 2x sub 4, I didn't mean to write the equal sign, plus 12 equals 0. Okay, how do we feel about setting up the equation matrix? And now, is this not just basic algebra? A two-step algebra situation where you're going to be adding, subtracting, and then dividing, correct? So, step 3 is to evaluate and find your values. So, what would I need to do here to get x1? Guys, anybody? Somebody? A typical algebra 1 two-step equation. What do you do? And then do what? Then I divide by 2, right? So I'm going to subtract 6, divide by 2. So I'm finding what x is. So x equals, building that. So I subtract 6, and I'm going to divide by 2. Agreed? And what does that give me? 8 minus 6 is 2, Miss Jones. Good job. And 2 divided by 2 is 1. Okay. On this one, I am adding 3, then dividing by 2. What is 5 plus 3? 8. What's 8 divided by 2? 4. On this one, subtracting 9, dividing by 2. 11 minus 9 is 2. 2 divided by 2 is 1. Subtracting 12, dividing by 2. And my last element would be negative 6. So let's recap what we did. We applied our scalar, and that gave us step 1. So we applied the scalar. We scalar multiplied. Step 2, we set up our equations. Step 3, we solve. What are your questions, comments, or concerns? You guys weren't really responding to me, so I don't know if the response is lack of response is because you're lost or confused, or lack of response is because it's so simple. I can't read minds. Any type of feedback would be awesome. Okay, still getting none. Cool. Well, here you go. I'm going to pause and stop talking because apparently you know it all. So here we go. Okay, so step 1 is we're going to apply our scalar. So I'm going to multiply all elements by, or you should have multiplied all elements by 2. 3 matrix x times minus, and you should have ended up with, should have negative 2, 14, 10, 0. Now, you could have distributed it as a negative, and then you would be adding. So either way works just fine. 17, 7, negative 7, negative 13, and 0. Okay, setting up your matrix with your equations. So you have 3x element 1 plus 2 equals 17. 3x element 2 minus 10 equals negative 13. Then we have 3 element 3 minus 14 equals negative 7. Bless me. And then we have 3x4 minus 0 equals 0. How'd you do setting up? I don't know why I just froze. My screen froze. Okay. How do we feel? Good? No one's like, oh, I can't do this. Cool. Okay, now you're going to evaluate. Solve. So I'm subtracting 2, dividing by 3. I'm adding 10, dividing by 3. I'm adding 14, dividing by 3. I'm adding 0, dividing by 3, correct? So what does x have to equal? Well, x has to equal 17 minus 2 is 15. 15 divided by 3 is 5. Negative 13 plus 10 is 3, negative 3, right? And negative 3 divided by 3 is? And we have negative 7 plus 14 is? And 7 divided by 3 is just 7/3. Fractions are our friends. And 0 divided by 3 is 0. How we do? Not too shabby. It's not terrible, right? All right, let's keep rolling. Matrix multiplication, okay? So with matrix multiplication, it's a little different. It involves multiplying and addition, okay? So when you're multiplying matrices, what you're following is a pattern. It's every element of the row in the first matrix times the corresponding element in the column in the second matrix. And then it's their sum that makes your new element. So here I have A times A11 times B11 plus A12 times B21. And that's going to be your next new element. And then you'll keep going. So now I have A11 times B12 plus A12 times B11. So again, it's the row elements times the column elements. And then the row elements times the column elements. And that makes your first new row. Then for your second row, it's the row elements times the column elements. Row elements times the column elements. So when you're looking back at the pattern, you should see similarities in the numbers. So each one in this column, notice, are being multiplied both by B11, being multiplied by B21, being multiplied by B12, being multiplied by B22. So you should see patterns when you're doing it. Another way is to look at it as, instead of all the extra numbers and letters, is just looking at the pattern with letters. So if I have A, B, C, D in matrix A, E, F, G, H in matrix B, when I'm looking at the pattern, it's element A times element E plus element B times element G. That's my first element in my product matrix. And then I repeat it again, element A times element F plus element B times element H. That's my second element in my product matrix. And then repeat, element C times element E plus element D times element G makes my third element in my product matrix. And then element C times element F plus element D times element H makes my fourth element. Okay, it's just a pattern to get the product. So this is our product. Because when you multiply two things, that's called a product. The result is. All right, let's apply some numbers. So we have element A times element B. And we're going to follow the pattern. So we have 2 times negative 1, 2, negative 1, plus 1 times 0. That's our first element. I completed 1 row times 1 column. That's an element. Okay, now we're going to do the next one, which is going to be 2 times 3 plus 1 times 4. That's another row times column completed. And now I've done each column. So I'm going to switch. I have -3 times -1 plus 0 times 0. I have -3 times 3 plus 0 times 4. So when I was a student, I learned to use the line method, and the line method just helps me remember, make sure that I've done each one the same amount of time. So as you can see, I've multiplied or I've used each element the same amount of time. Do you see that? And now you're going to evaluate. So when we evaluate, so I have -2 plus 0. What is that going to give me? -2. I have 6 plus 4. That gives me 10. I have 3 plus 0. That gives me. I have -9 plus 0. And so this is my product matrix. Question. So matrix multiplication is a combination of addition and multiplication. All right. Here's yours to try, and this is going to be where we stop at for today. Okay, so you had A times B equals, and remember you're doing row times column. So you have 2 times -3 plus -1 times 0. That's your first element. I have 2 times 1 plus -1 times 2. And I know that 3 and 4 are going to repeat the same process, right? So we have 3 times -3 plus 4 times 0. Then we have 3 times 1 plus 4 times 2. How do we do? Huh? On the first one? Yes. Are we good? I'm going to talk about the setup. Are we good? All right. So now we are going to evaluate. So yes, -6, then perfect. And there's your product matrix. How we do? Once you complete that first row, did you notice that the second row just follows suit? Oh, that's 11. Because I added 4 and 2 in my head instead of multiplied them. You saw nothing. Never saw it. All right.